Properties of the compounds are altogether different from the elements from which it is obtained or it is formed, and the constituent of the compound cannot be separated mechanically. So the formation of compounds involves energy changes. Mixtures. The combination of two or more substances which are physically mixed and are not chemically combined with each other and may also be present in any proportion, that we call as a mixture. There are mainly two types of mixture, that is homogeneous mixture and heterogeneous mixture. Types of mixture. Mixtures are classified as homogeneous and heterogeneous on the basis of their physical properties or composition. So first one is that homogeneous mixture. It is a mixture which has a uniform composition and the particles of the mixture are not visible by the naked eye. The particles cannot be separated by filtration. The mixture is stable, that means the particles do not settle down. The path of beam of light is not visible in the mixture. For example, mixture of sugar in water, mixture of salt in water, and the mixture of copper sulfate in water, etc. Then the second type is heterogeneous mixture, which is a mixture which has a non-uniform composition. The particles are visible by the naked eye and the particles can be separated by filtration method. The mixture is unstable, that means the particles settle down. The path of a beam of light is visible in the mixture. For example, the mixture of salt and sand and the mixture of sulfur and iron filling, mixture of oil and water, etc. Differences between mixture and compound. Mixture. It is composed of two or more elements or compounds mixed together. While compound, it is composed of two or more elements chemically combined together chemically. Chemically combined together chemically means here it will be combined with a chemical bond. Second one, that the composition of the constituent is not in fixed ratio, while in compound the composition of the constituent is in fixed ratio. Third, it shows the properties of all the constituents, while in compound it shows the different properties than the constituting elements. That means the property will be entirely different from that element or that compound. Then the next is the components can be separated by physical method, while in compound the components can be separated only by that chemical methods. True solution. A true solution is a homogeneous mixture of two or more non-reacting substances whose composition can be varied with certain limits. A solution has a solvent and solute as its components. The component in the larger amount is the solvent and that the component in the lesser amount is the solute. For example, solution of salt in water, solution of sugar in water, iodine in water, that we call as tincture iodine, and soda water, etc. There are some properties of true solution, and that properties are: true solution is a homogeneous mixture and the particles cannot be seen by the naked eye because the solute particles are very small, that is less than 10 to the power minus 8 centimeter in diameter, and the solute particles cannot be separated by the filtration due to its diameter, and the solute particles do not settle down and the solution is stable. The particle do not scatter a beam of light passing through it and the path of light is not visible in the solution, and that we call as a Tyndall effect, which can be studied later. And the entire solution which can be passes through that filter paper, so it cannot be filtered. And then the particles do not settle because due to that its gravity only, and the particles which are not be visible even with a powerful microscope. Types of solution, that is saturated solution and unsaturated solution. Saturated solution is a solution in which no more of that solid, that is solute, can be dissolved at a given temperature, while unsaturated solution is a solution in which more of the solid can be dissolved at the given temperature is called an unsaturated solution. Then what is solubility? Solubility of a substance is the amount of solute present in a saturated solution of the substance. Then how that preparation of the saturated solution takes place. Take 50 ml of water in a 2 beaker, add salt in 1 beaker with continuous stirring till no more salt dissolve in it. Similarly, add sugar in that other beaker with continuous stirring till no more sugar dissolve in it. We get saturated solution of salt and sugar. If the mixture are heated, it dissolves some more of that solute. The solubility of different substances are different. The solubility of the substance varies with that temperature. Concentration of solution. The concentration of a solution is the amount of solute present in a given amount of the solvent or solution. In other words, we can say that concentration of a solution may be expressed in terms of percentage by mass of solute per 100 gram of the solution. For example, 100% of that concentration of solution means that the mass of solute by mass of solution into 100. In other ways, we can explain by that example. If we consider that if a solution is 5%, it means it is 5 gram of a solute dissolved in 100 gram of the solution, or it contains 5 gram solute if it is in solid form and 95 gram solvent. And the concentration of the solution may also be expressed as that the mass of solute dissolved in 100 centimeter cube of the solution. Thus, that means 10% sugar solution by volume means 10 gram sugar dissolved in 100 centimeter cube of solution. Colloidal solution. Colloidal solution is a heterogeneous mixture of two or more substances. For example, mixture of starch in water, mixture of egg albumin in water, milk, air containing dust and smoke, etc. Then the properties of colloidal solution. Colloidal solution is a heterogeneous mixture. It appears to be a homogeneous, but actually it is heterogeneous mixture of solute and solvent. The particle cannot be seen by the naked eye because the solute particles are between 10 to the power minus 7 and 10 to the power minus 5 centimeter in diameter. The solute particles cannot be separated by filtration because of that size, and the solute particles do not settle down and the solution is stable because the particle do not settle due to its gravity. And the particles in a colloidal solution flow zigzag path, and that particles scattered a beam of light passing through it, and the path of light is visible in the solution. That means the particle shows Tyndall effect, and the particles can pass through that ordinary filter paper also. This is all about that the colloidal solution. Tyndall effect, which is an important topic in this chapter. When a beam of light is passed through a colloidal solution, the colloidal particles scatter the beam of light and the path of the light become visible in the solution. This effect is called Tyndall effect, and the Tyndall effect can be seen when light enters a room through a small hole due to scattering of light by the dust and the smoke particles. Tyndall effects can be seen in a dense forest due to that scattering of light by water droplets in the mist. So we can say that the illumination of beam of light due to scattering on collision with certain particles is called Tyndall effect. In dense forest, particularly in the early morning, there is a fog, that is, tiny water droplets are suspended in air, and these droplets are large enough to scatter beam of light. This is why that the Tyndall effect can be observed when sunlight passes through that dense forest. Suspension. A suspension is a heterogeneous mixture of two or more substances. For example, solution of sand in water, solution of chalk powder in water, etc. And the properties of suspensions are that suspension is a heterogeneous mixture, and the particle can be seen by that naked eye because the solute particles are quite large, that is larger than 10 to the power minus 5 centimeter in diameter. and the particles are visible even with that naked eye. The solute particles can be separated by filtration because of its size, and the solute particles settle down and the solution is unstable because the particles may settle due to that gravity, and the solute particles that means scattered a beam of light passing through it, and then the path of light is visible in that solution. That is Tyndall effect. That means they may or may not show Tyndall effect. Here the pictures are given for that the properties of suspension. So we conclude that suspension is a heterogeneous of mixture of that solid in a liquid, and the suspension is formed when a liquid contains small solid particles which are not soluble in it but are visible to naked eye. If such a mixture is left undisturbed, the solid particles slowly settle down to that bottom under that effect of gravity. If the particle size of the solid is greater than 10 to the power minus 5 or minus 7, then it is insoluble in that given liquid. Then the solid particles remain suspended in that liquid, and this is called as a suspension. For example, mud water, sand water, and that coarse limestone particles in water. Here the picture also be given that solute particles can be separated by the filtration method, and the solute particles settle down and the solution is unstable. So the solute particles scattered light, that also be shown in this diagram.